Today we can discuss the nomenclature. Last class we discussed up to ethers. Today we can begin it with the aldehydes. Nomenclature of aldehydes. Aldehydes are named as alkanals. Alkane, alkane, the terminal E is replaced by Al. Alkanal. And here CHO group is a terminal group. That means when you number the carbon atoms, you have to start numbering from CHO, numbering from CHO. So CHO group will get number 1 always. So in an aldehyde, you have to start numbering from CHO group. That is very important. Here 3 examples are given. First one is CH3, CH, CH3, CH2, CHO. So when you start numbering, you have to start numbering from here. 1, 2, 3, 4. So 3-methyl butanol. 3-methyl butanol. Always CHO group is number 1. Therefore, no need to mention the position of the CHO group with a number. So here, how can you name this compound? You can name it as 3-methyl butanol. 3-methyl butanol. So before getting this name, you have to write it yourself. Then only you will understand what are the problems associated with this process of nomenclature. Okay, now the next compound you can see. So you have to start numbering from this CHO group. 1, 2, 3, 4. If it is to this side, again 1, 2, 3, 4. To the two sides it is same. We can consider it as the substituent. How many carbon atom? 1, 2. 2 carbon atom, therefore it is an ethyl substituent. Ethyl substituent. So 2-ethyl butanol. 2-ethyl butanol. That is the name of the compound. 2-ethyl butanol. Okay, now in the third case, 2 functional groups are present, OH and CHO. In this case, not 2, 3 functional groups are present. There is a Cl also. In this, we have to select the principal functional group out of Cl, OH, and CHO, which will get the most preference. CHO will get preference over OH and Cl. So you have to give preference to CHO. CHO will get number 1, number 2, number 3, number 4, number 5. So in the 5th carbon atom an OH group, 4th carbon atom a Cl group, and in the 2nd carbon atom a CH3 group. So except CHO, all of this will be considered as substituents. It is a methyl substituent, it is chloro substituent, it is hydroxy substituent. So according to the rules, IUPAC rules, we have to follow alphabetical order. So 4-chloro, 5-hydroxy, 2-methyl pentanol. 4-chloro, 5-hydroxy, 2-methyl pentanol. So here you can see only 3 examples, but you have to try to name these compounds yourself. So after watching this video, you just write down the structure of the compounds only in your notebook. Then after watching this video, you try to name these compounds without referring to the video, and later you can check whether it is correct or not. That way you can study it well. And also you have to solve the problems given in the NCERT textbook. Okay, now we can go to the next group, that is ketones. The functional group is divalent CO. That is a functional group, ketone. They are named as alkanone, means alkane terminal E is replaced by ONE. So here the first compound is CH3, COCH3. How many carbon atoms are present? 3 carbon atoms. What is the name of the corresponding alkane? Propane. Terminal E is replaced by ONE, propanone. So here the name of the ketone, the first one. What is the name of the ketone? The first one, propanone. So you can see propanone. Now in the second compound, how many carbon atoms are present? 1, 2, 3, 4, 5, 6. 6 carbon atoms are present. Here there are several possibilities for the presence of CO group. It can be in the second carbon atom, it can be in the third carbon atom. 1, 2, 3. If you start from numbering from here, 1, 2, 3. So 2 possibilities are there. It can be in the second carbon atom or it can be in the third carbon atom. It is not the fourth carbon atom. If you start numbering from this side, 1, 2, 3, it is the third carbon atom. So since there are 2 possibilities, clearly you have to mention which carbon atom is CO group. So here if you start numbering from this side, 1, 2, second carbon atom is CO group. Total how many carbon atoms? 6. So it is actually hexanon, but mention where is the CO group. It is in the second carbon. So hexan 2-on, that is the name of the compound. Hexan 2-on, that is the name of the compound. I think it is clear to you. Now see this bond line structure. In this bond line structure, CH3, CH2, C double bond O, CH2, CH3. This case also CO group. It is the CO group or ketonic group. 1, 2, 3. If you start numbering from this side, 1, 2, 3, it is the third carbon atom. If you start numbering from this side, 1, 2, 3, it is the third carbon atom. So if you start numbering from left side or right side, there is no problem. So start numbering from this side, 1, 2, 3, 4, 5. 5 carbon atoms, so it is pentanone, but where the CO group in the third carbon atom, so pentan 3-on, pentan 3-on. That is the name of the compound. Now the nomenclature of amines. Amines are named as alkanamines. Alkane, terminal E is replaced by amine. What is the function group? NH2 group is the function group. There are 3 types of amino groups: primary, secondary, tertiary. You will study it in second year in detail. There you have a chapter in organic chemistry that is about amines and diazonin salt. There you can study it in detail. Amines. So here we will discuss only the nomenclature of primary amines, that is NH2 group, if NH2 group is present. Alkanamine, it is named as alkanamine. 2 examples are given here. In the first example, you see NH2 group is attached to this carbon atom. We will give preference to the functional group. If there is no other substituent, so it will be number 1, number 2, number 3. 3 carbon atoms of propane. Terminally is replaced by amine, propanamine. But here NH2 group can be attached to the first carbon or second carbon. So you have mentioned the position of NH2 group. So propan 1 amine. That is the name of this compound. Propan 1 amine. And here in the second case, NH2 group is present here. So we have to start numbering from this side. 1, 2, 3, 4, 5. So pentanamine. Where is NH2 group in the second carbon atom? Pentan 2 amine. That is the name of the compound. Pentan 2 amine. Pentan 2 amine. That is the name of the compound. So it is nomenclature of amines. So here CO group and NH2 groups are not terminal groups. So we cannot start numbering from the carbon atom carrying CO or NH2 group as 1. But in the case of aldehyde, we can start numbering from CHO group. Similarly, in the case of cyanides, also we can start numbering from CN. CN as number 1. CN also a terminal group. Cyanides are named as alkane nitrile. Alkane nitrile. Nitrile. We are adding nitrile to represent a cyanide. So here what you have to listen, start numbering from CN group. So in the first example, start numbering from here. 1, 2, 3, 4. So since there are 4 carbon atoms, it is butane. But The first one is nitrile. So butane, nitrile, butane, nitrile. Here also, in this bond line structure, you have to start numbering from Cl. 1, 2, 3, 4, 5, 6. This hexane nitrile, but in the second carbon atom, an ethyl substituent is present. So 2-ethyl hexane nitrile. 2-ethyl hexane nitrile. That is the name of this compound. 2-ethyl hexane nitrile. The next one is carboxylic acid. Carboxylic acids are named as alkanoic acid. Alkane terminal E is replaced by oic acid. OIC, oic acid. Alkanoic acid. COH group also considered as a terminal group. So when you start numbering, start from COOH. Here you can see an example here. Number 1, 2, 3, 4, 5. It is pentanoic acid. No need to mention the position of COH groups. What is the reason? Always it will be 1. So simply say pentanoic acid. It is pentanoic acid. And the second example has only one carbon atom, so the name is methanoic acid. There is no confusion. Methanoic acid. Carboxylic acid. Nomenclature of carboxylic acids. Now the nomenclature of cyclic compounds. It is not cyclohexane. What is the reason? There is a double bond here. So when you number, the double bond will get preference over the substituents like NO2, Cl2, CH3, such groups. So here you give preference to double bond. So number from here 1, 2, 3. So 3-nitro cyclo, it is not hexane, it is hexene. So you have to mention where is the double bond. Hex 1E. 3-nitro hex 1E. Cyclo hex 1E. And here in this name you can see that one is not mentioned. In such compound, in cyclic compounds, if the number is not mentioned, if nitro group is 3, it is very clear the numbering is started from the double bond 1. So it is not compulsory to give a number 1 here. So simply you can write 3-nitrocyclohexene, 3-nitrocyclohexone, or you can write 3-nitrocyclohexene. Here the number that is not compulsory since it is cyclic. What is the reason? Always you will start numbering from the double bond. So the double bond will be at number 1. That is understood. Therefore, it is not compulsory to mention the position of the double bond. It will be 1. So 3-nitrocyclohexene or 3-nitrocyclohex-1A. Now here OH group will get preference over the double bond. OH group will get preference over the double bond. So in this case, when you name, you have to mention the position of double bond. That is compulsory. So if the double bond is here, there is such a chance. In the third carbon atom, it can be in the third carbon. Here it is in the second carbon atom. It also can be in the third carbon atom. Since there is a confusion here, compulsorily you have to mention the position of the double bond. So if an OH group is attached to benzene, that is phenol. Benzene, that is phenol. But it is not benzene. Only one double bond is present here. So it is actually cyclohexene, cyclohex 3E. And OH group all can be represented as all. So cyclohex 2-ene 1-ol, cyclohex 2-ene 1-ol. That is the name of this compound, cyclohex 2-ene 1-ol. Now the nomenclature of substituted benzene compounds. It is taken from the textbook. So you can see a methyl group is substituted in benzene. If there are only one substituent, no need to number the carbon atom, just to say methyl benzene. Methyl benzene, also known as toluene. This name also recognized by IUPAC. So methyl benzene or toluene. An alkoxide group, OMe means methoxy. OMe means methoxy, OCH3. That is the meaning, OCH3, methoxy. Methoxybenzene, also known as anisole, that also recognized by IUPAC. Methoxybenzene or anisole, OMe, methoxybenzene or anisole. Aminobenzene or anisole, aminobenzene or anisole. It also can be named as benzenamine, benzenamine or aminobenzene or aniline. These are the names that can be given to cis-H5 NH2 group. And NH2 group is substituted in benzene. Now it is nitrobenzene. A nitro group is substituted. So nitrobenzene, bromobenzene. If there is only one substituent, no need to give any number to the carbon atoms. Simply say bromobenzene or nitrobenzene. If there are more than one substituent, then we have to give number to the carbon atoms. Here, 3 examples are given. The first one is dibromobenzene. Sorry, all the 3 are dibromobenzenes. But what is the difference? Only in the position of bromine. Here, if you number this carbon atom as 1, the second carbon atom also bromo. There is a substituent, bromide substituent. So this compound can be named as 1,2-dibromobenzene. 1,2-dibromobenzene. Here the bromine atoms are substituted in 1, 2, 3. 1 and 3 carbon atoms. So what is the name of this compound? What is the name? 1,3-dibromobenzene. And it is named as 1,4-dibromobenzene. 1,4-dibromobenzene. 1,2-dibromobenzene, also known as ortho-dibromobenzene. Ortho. Second position is named as ortho in common name. And the third position is named as meta-dibromobenzene. And the fourth position is named as para-dibromobenzene. So 1,2-dibromobenzene, 1,3-dibromobenzene, 1,4-dibromobenzene. Another example, 3 substituents are present. So here we have to give preference according to the alphabetical order. What is the reason? All these are substituents. So chloro will get preference over nitro. Start numbering from here. 1, 2, 3, 4. So in this direction, you have to proceed in this direction. NO2 group will get number 2. If you are proceeding in this direction, 1, 2, 3, 4, NO2 group will get number 4. So you have to proceed in this direction. 1, 2, 3, 4. So 1 chloro, 2,4-dinitrobenzene. 1 chloro, 2,4-dinitrobenzene. Another example. Here chloro, methyl, nitro. 3 groups are present. Chloro, methyl, nitro. Here, if CH3 group is substituted in the benzene ring, we can consider it as toluene. So if you are naming this compound as the substituent of toluene, you have to start numbering from methyl group. Here, 1, 2, 3, 4. Then what is the name? 2-chloro-4-nitro-toluene. That is one of the names. Otherwise, you can consider it as substituent of benzene. So in that case also, here chlorine is in between, middle. So you cannot start numbering from chlorine, either from CH3 or from nitro. So if you start numbering from methyl, chlorine will get 2. If you are start numbering from NO2, chlorine will get number 3. So it is preferred. Start numbering from methyl. 1, 2, 3, 4. Then 2-chloro, 1-methyl, 4-nitro, benzene. 2-chloro, 1-methyl, 4-nitro, benzene. Otherwise, what is the name? 2-chloro, 4-nitro, toluene. 2-chloro, 4-nitro, toluene. Substituted benzene. Yeah, numbers are already given. Uh, Here it started numbering from here. What is the reason? Because we named it as anisole. If OMe group is substituted in benzene, it is named as anisole. So 2-chloro-4-methyl anisole. 2-chloro-4-methyl anisole. Here, if NH2 group is substituted, we will call it as aniline. Aniline. So 4-ethyl group is present here in the fourth position. Second position, methyl. So 4-ethyl, 2-methyl aniline. 4-ethyl, 2-methyl aniline. And the last one, OH group is present in the benzene ring. We will call it as phenol. Methyl, 2 methyl groups are present in third carbon and in the fourth carbon. So 3,4-dimethyl phenol. 3,4-dimethyl phenol. That is the name of the compound. Okay, now isomerism that we can see in another class. Okay, today we can stop it here to study.